Right, let's go through the question. In the diagram, EF is parallel to ADC. EF is parallel to ADC, and BFC is parallel to ED. Right. This information is very, very crucial. Right. Prove that triangle BEF is similar to triangle EAD, and then thereafter prove that AD over ED is equals to EF over BF. Right. This information here is about parallel lines. So what do we know about geometry of parallel lines? We know of the corresponding angles, alternate angles. Corresponding angles are equal, alternate angles are equal. Okay. There is co-interior angles, but remember, co-interior angles are supplementary. They add up to 180 degrees. They are not equal. So here we're talking about equal angles. So it may involve corresponding angles or alternate angles. Right, now prove that triangle BEF is similar to triangle EAD. Now let's match our angles. Let's match our angles. So we have angle B goes with angle E. Let me just highlight the triangles. Okay, you can even do this in the exam. Just highlight the triangles in the exam using your highlighters so that you can identify them, and then you see the triangles you're dealing with. So these are the triangles here. So it's BEF and EAD. So angle B goes with angle E. So which E there? It should be E3, isn't it? So if you check, it should be E3 there. So we can say angle B should go with angle E3. Right? And then we go to our statement again. E goes with A. E in triangle BEF. So E with A. So E should be E1 there. In triangle BEF, E is E1. So angle E1 is equals to, or this means just, I'll match it with A. Okay, right. Check that we are starting with the angles of BEF followed by angles of what? Of EAD. And then the last pair is F and D. Okay, F, so it means they should be F1. So F1 should be, we're matching it with D, so it means it should be D2 there. You see that? Okay, right, now let's write our statements with reasons. So in triangle BEF and triangle EAD, angle, which one can we start with? I think E1 and A there, isn't it? So angle E1 is equal to A. Why is angle E1 equals to A? Angle E1 is equal to A. These are corresponding angles. Okay, they are equal because they are corresponding angles. And then we can say that EF is parallel to ADC. So these are corresponding angles. And then we go to B. What about B? B is equals to what? Angle B is equals to angle B is equals to angle what? E3, isn't it? Angle B is equals to angle E3. Why? Angle B is equals to angle A3. These are the two angles, right? Why? They are corresponding angles, if you check. Corresponding angles. Okay, since BFC is parallel to ED. Okay, even if you say just say BC is parallel to ED is fine. Right, and then we have our third pair. Right now, it means F1, angle F1 is equals to angle D2. Why? Third angle of triangle. Third angle of triangle. So now we have managed to prove that we have three pairs of corresponding angles being equal. Right, and then now we can conclude and say, therefore, triangle BEF. If you check B here, goes with E. So it's similar to triangle E, then E goes with A. E goes with A, then A, and then F. F goes with D. EAD, right? And then what's the reason? You can even write like this: angle, 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 right? Okay, right. We've done the first part of our question. We proved that triangle BEF is similar to triangle EAD. Right, now let's go to the second part. Remember, we have managed to prove that triangle BEF is similar to triangle EAD. So from this statement, we can conclude and say BE over EA is equals to EF over AD is equals to BF over ED. And then the reason here, we're saying similar triangles. Okay, right. Now let's check what the size that we have here. We have AD there. And then where is AD? Here, we have it here. ED, we have ED there. EF, we have EF there. And then BF, we have BF there. So therefore, EF over AD is equals to BF over ED. Okay, right. So now, what can we say? What can we say? Right, we have this. How can you transform this statement to look like that? So what do we do here? Let me remind you about something. Let me use just equivalent fractions just to remind you. Right, okay, common fractions. Let's say I have 3 over 6 is equals to, let me multiply this one by 3. Let me use 2. 3 times 2 is 6. Then 6 times 2 is 12. Okay, these are equivalent fractions. Right, if you check, I can say 3 over 6 is equal to 6 over 12. Do you agree? So 3 over 6, which is half, remember, is equal to 6 over 12, which is half. Do you see that? So we can do the same thing here. We can do the same thing here. So we can say AD over ED. We're taking this part here. AD over ED. So it's AD over ED. Okay, don't forget therefore. And then is equals to EF over BF is equals to EF over BF. Done. So we've managed to prove the second part of our question. Let's meet in our next lesson, which is going to be activity 7.